Hello students, today we start Unit 4. Entire Unit 4 related to data analysis. Previously we came to know how to collect the data in the Unit 3. That means how to frame the questionnaire and what do you mean by primary data, secondary data, and what are the measures, what are the observations required while preparing the questionnaire, and what kind of data types would be there, like NOIR. What do you mean NOIR? Nominal, ordinal, interval, ratio type kind of data. Understand? Now in this unit we are going to understand, so after getting the data, how to extract the information from the available data, whatever data is there after primary or else what you call the secondary methods. So what you call this aspect is known as the data analysis, which is most important. Actually, whenever a data analysis required, the specialists about the data analyst will be what you call doing this job. So here actually we are going to understand how to analyze the data. So analysis means extracting the information. Hundreds of values would be there, thousands of values would be there. Let us take what you call the marks of a class itself. In a class, let us suppose that 60 students would be there. Let us suppose that 6 subjects are there. So 6 into 6, 360 observations will be there. Understand? So what these 360 observations, these 360 numerical values going to inform to you, and what are the insights we can have from all these 360 values, you need to understand. So understanding all this information is known as the analysis of the data. Through the analysis, you are going to understand actually what are the problems, what are the observations, what are the learnings about the data. So in this small what you called class, which is having 60 students, understand, you got these many numerical values. Let us take the data related to sales of a particular supermarket. Per week data itself, if you take, thousands of transactions would be there. You will be observing in the week beginning sales of only few kinds of products. On Sundays, on weekends, few kinds of what call the product sales will be very, very high. In mid of the week, what you call demand will be there for few kinds of products. So such a way, this information you are going to extract after finally analyzing the data. So marketing analysts you call. So these are all specialized people. You got the wonderful opportunity. So after finishing your MBA, you take up any course related to marketing analytics. So you will be having less competition. And in the market, so many good jobs are there. So these marketing analysts, what they do, they are going to give various what you call informative figures to the what you call the decision makers, and based upon that the decision makers, the in charge of that particular superstores or the higher authorities are going to make so many what you called good decisions. So that is the purpose of what you call the data analysis. Now if you take the present situation, in upcoming 10 years, in upcoming decade, if you see the what you call the list of the jobs as per my information, so from top 5 jobs if you consider, so the data analyst jobs are going to be within that top 5. So that much huge demand is there if you consider what you call think about the data analyst job throughout the world. So here these are the starting steps to all of you. So here in this MBA, especially in this BRM, you are going to understand for what we call smaller scale data how to analyze. Okay. So actually when you are going to understand about the data analysis, you need to understand about the inferential statistics. What do you mean by inferential statistics? So inferential statistics is nothing but the branch of a statistics itself. Like there are different types of statistics available. Mathematical statistics is there. Descriptive statistics is there. Okay. So based upon the kind of area that particular vertical statistics is going to cover, that name will be given. Here the inferential statistics means here the entire tools are going to explain, going to infer about the population. This is very, very important thing. So you already introduced the what you called very, very important definition as far as the statistics is concerned, population. So what do you mean a population? A population is nothing but the group of individuals, the group of things, the group of articles on which you are conducting any statistical investigation. That might be patients, that might be what you call automobile, that might be electronic items, that might be what you call the goods in a supermarket, whatever may be. All those collection of what you call the things you are calling as the population. So inferential statistics is nothing but which is going to infer about that population. So let us suppose that here very, very latestly you will be observing the diesel petrol prices are what you call upshooting. Most of us looking what you call towards any other alternative of what you call vehicles, like electrical vehicles are there. So few companies have been introducing electrical scooters into the market. Understand? Now as you all know very well, immediately from this petrol diesel kind of vehicles to shift to this what you call electrical vehicles, most of the times we think, most of the time we reluctant to take any decision. So through this statistical inference what happens, a statistical investigation will be performed on any group of what you called, let us suppose who wants to purchase two-wheelers in upcoming few months, and we can understand, we can measure their pulse. Really they are what you call willing to what you called purchase the electrical scooters like this. So there that group, what you call group of individuals becomes our population. Understand? The information whatever you get finally after conducting all this statistical investigation is known as the inferential statistics. Understand? Let us suppose that if you want to know all the what you call the people opinion about the electrical scooters who are there in South India, entire South India public, the entire South India people become your population. Now tell me, within a short period of time, within 1 week, within 10 days, will it be possible to have what you called the standard reliable information from all the people who are what you call living in South Indian states? Because here the time duration is very, very less. Then what is the technique you are using here? Sample. Nothing but you are going to research to take the samples from various states, you are going to understand. Getting my point? So what do you call these sampling methods or sampling techniques? You know very well, like probability sampling methods are there and non-probability sampling methods are there. Understand? So here the point you need to observe is, when you are going to understand about the population, there are what you called two courses are there, two directions are there. One is called theory of estimation and one more is called hypothesis testing. This is very, very important. That means the inferential statistics have been diverted into two branches. One is called theory of estimation and one more is called hypothesis testing. Inferential statistics means getting information from the population, that you know. But to understand about that population, two branches of statistics, two branches of what we call tools are available. One is called the theory of estimation and as well as hypothesis testing. Then when do you use the theory of estimation? And again, when you are going to what to call use this hypothesis testing. Very, very important discussion this. So the theory of estimation is useful actually when you are going to read or when you are going to understand about any population, whenever there is no information is available about that population. I'll explain this one with a wonderful example. And one more thing. When you are going for using the hypothesis testing means, when you are going to understand about the population, that too when you know something about the population. See, both are different situations here. In first situation, you don't know about the population, but still you need to get information about that population. Then the technique in the statistics is available. Apply all estimation methods. But you want to know about the population, but something you know about that population. With that available information, if you want to know some extra information, or else the available information about the population is correct or not, if you want to test. What do you call this? The hypothesis testing. Understand? Now I will give you a wonderful example here. Now look at here. Here there are two cities. One is called city A, city B. Okay. So as you all know that after finishing your course, most of the times we actually pick up a job. Let us suppose that you have been selected for a particular job and you asked to join that job in a particular city. Let us suppose that city A. But the amazing thing is you don't know about that city. You never visited that city before. Understand? But compulsorily you need to go to that city and you need to take up the job, because job is a good offer. You are going to have handsome salary. Then what you will do? You are going to get information about that city A. So in that city A, where is your office? After joining over there, where to stay? And what are other facilities are available in that particular city. Okay. So whenever you are conducting any statistical investigation of a city A kind population, the technique you need to use nothing but the theory of estimation. Now let us come to one more city. What is this city B? Let us suppose that you actually got the opportunity city B, but you are very much well aware of the city B. Your known people are there, your friends are there. You know what are the things available in the city, the particular location also. Then what you will do here? Happily you go to that city, but still you will start doing information gathering, whether those available things are available in that particular thing or not. The information is fact or not. Understand? You are comparing, you are testing. In such a kind of situation, you are going to apply what kind of test? Testing of hypothesis. Understand? Strictly speaking, in terms of statistics, so here, as you know very well, so what do you call this? This you are calling as the mean. So generally, mean is represented by x bar. And one more very, very important aspect as far as what called statistics is concerned, what you call this standard deviation. Square of the standard deviation, what you are calling? You are calling the square of the standard deviation as what you call variance. Understand? So in terms of statistics, whenever the mean variance of the population is given, whether that mean variance value is correct or not, to test is known as the testing of hypothesis. Whenever the mean variance or any other information about the population is unknown to you, then you are going to identify that information. What do you call that? Estimation. So estimation in a general terminology, what do you mean by that? Approximation. Approximately, by using statistical techniques, you are going to understand, you are going to calculate the mean and variance of the population. This is what actually the major difference between theory of estimation and as well as the hypothesis testing. The theory of estimation you are going to apply when you are going to understand about the unknownness of the population. The hypothesis testing or in the testing of hypothesis, this technique you are going to apply whenever already some information will be known about that population. You are going to identify whether that information is correct or not. Understand? Now, in upcoming slides, we are going to understand exclusively about the theory of estimation. That means understanding about the unknown population. We don't know any information about that city. After that, we are going to understand about what we call the hypothesis testing. Okay? So, what do you mean by theory of estimation? Theory of estimation or else estimation theory. When you are going to understand the estimation theory, you are going to very frequently get these three variety kinds of words. One is called, the first one is estimator, the second one is the estimate, and the third one is called the estimation. What do you mean by an estimator? An estimator is a function of sample. It is a rule that tells you how to calculate an estimate of a parameter from a sample. So an estimator is nothing but the formula, statistical formula. You know, so many formulas till date, understand? Simple example, arithmetic mean is there. What is the formula? Sigma xi by n. What do you call that? Estimator. So by using that formula, that estimator, you are going to get one numerical value. That numerical value, what you are calling as the estimate. I mean to say the answer. So, what is the example? Let us suppose the sample mean is x bar. So, after using that formula, let us suppose you got the answer as 60. That means that the x bar is known as the estimator. This numerical value 60 is known as the estimate. The effort, whatever you made from the estimator to estimate this 60, you known as the estimation. Be careful. That means all the what you call workout, substitution, calculation, all these things, understand? Whatever you have performed from the estimator to get the estimate is known as the estimation. So there are so many estimation methods are there, like maximum likelihood estimation method, MLE, those are all pure statistics. Moments method is there, mu1, mu2, mu3, these are all called moments method. So centralized moments, non-centralized moments, understand? So based upon these methods, we are going to have the estimation process. So meanwhile, we should have beforehand the estimator and as well as the estimate. So what is an estimation here? Process of estimating population parameter from a sample statistic is called as the statistical estimation. That is, in any statistics, numerous procedures used to calculate the value of some property of a population from observations of a sample drawn from the population. Very, very important discussion this. So within the estimation, estimator would be there, estimate would be there. So estimator is nothing but the algebraic relation, the function, the formula. So by substituting various values in that formula, you get the answer. What do you call that? Estimate. That procedure you are calling as the estimation. So while understanding the estimation here, we come across two very, very important words. What is that? The first one is called statistic, sample statistic. And one more word, what do you call this? The parameter. Already we come across this word parameter while discussing the distributions. So binomial distribution parameters are n comma p. Normal distribution parameters are mu comma sigma square. The only one discrete distribution in this world which has got both mean variance as equal, unique. What is the distribution? Poisson distribution. So what is its parameter? Lambda. So there the parameter means very, very important value. But in the what you call the inferential statistics, very often you get the parameter once again. But here you have to remember that the parameter in the inferential statistics means all the numerical information about the population. That means the population mean, population variance, population standard deviation, whatever numerical information, if you calculate from the population, what you call that? The parameter. Same way, statistic, sample statistic. Sample statistic means any statistical information. If you are going to calculate not for the population but the part of the population, the subpart of the population, what do you call that subpart? The sample. That means the sample mean, sample variance, the sample standard deviation, the sample correlation, the sample regression, all these are all known as the statistics. So besides that, we are going to cover now few very more important what you call definitions. So till now what we come across, we came to know what do you mean by inferential statistics. The inferential statistics is nothing but inferring about the population, understanding about the population. The inferential statistics divided into two branches. One is called estimation theory or as a theory of estimation, and one more is known as the testing of hypothesis. So estimation theory means you are going to understand that kind of population. For that you don't have any kind of prior information. The testing of hypothesis method you are going to apply when you actually know something about any population, whether that information is correct or not. Okay. Now let us see the important definitions under the estimation theory. Okay. The first definition is parameter. Don't confuse the parameter of what you call distributions, the parameter of what you call population in inferential statistics. The parameter in the inferential statistics means a fixed information, a fixed characteristic of the population based on all the elements of the population is termed as the parameter. It is a numerical value that remains unchanged. Always population parameters are fixed. Same way, then what is a statistic? So statistic, I am not putting S, you observe the spelling. Statistic means, a statistic is defined as a numerical value which is obtained from a sample of data. It is a descriptive statistical measure and function of the sample observations. The common use of the statistic is to estimate a particular population parameter. Okay. Now, look at here. From now onwards, you have to be very, very careful about the notations. All the sample information, whatever you are going to get, will be denoted by lowercase alphabets and also lowercase what you call Greek letters. Same way, all the population information what you are going to get from now onwards, higher case English alphabets or higher case what you call Greek letters will be used. Now here you see the sample mean. In general, the mean means we actually know just what you call writing bar over the x. But here from now onwards the sample mean is small x bar. Same way, the population mean means mu. So what is how to pronounce this? Mu, Greek letter. Same way, the sample standard deviation. What is this? Small s, lowercase letter s. The population standard deviation, sigma. Sample proportion, we are going to use, what is the sign? The symbol small p, lowercase p. The population proportion, we are going to apply with symbol capital P. So data elements, small x, data elements, the items in the population, you are going to represent by means of capital X. The size of the sample, small n. The size of the entire population, capital N. Correlation coefficient of the sample, denoted by small r. The correlation coefficient of the population, you are going to represent by means of the rho. What do you call this? Rho. Again, sample size, already covered this. Sample size represented by means of small n. Same, now here also population size represented by capital N. So these are all parameters, these are all nothing but the statistics. So in the estimation, what you are doing actually, through this statistical information, you are going to identify what to call this, the population values. Okay. Now, these two are very, very important definitions. What do you call this? The sampling distribution. What is a sampling distribution? A sampling distribution is a probability distribution of a statistic obtained from a larger number of samples drawn from a specific population. It describes a range of possible outcomes that of a statistic, such as the mean mode of some variable as it truly exists a population. Okay. Now all of you look at here. Now I am going to explain with this example what is a sampling distribution. Let us suppose that this entire big circle is the Hyderabad city. Okay. And let us suppose that you want to know in this entire Hyderabad city what is the business actually doing by all the supermarkets. So in Hyderabad there are so many, n number of supermarkets are there. Okay. Will it be possible within what you call 2 or 3 days to get to what you call go to all these supermarkets and to have the information? So it's very difficult. Then what you are doing, you are taking what you call few supermarkets, let us suppose in one of the prominent areas of what you call Hyderabad, like Mehdipatnam. So from that area, whatever sample information you got, let us suppose that you are going to represent by T1. Same way, let us suppose that from Dilshuk Nagar, the information whatever you got T2. Same way, let us take what you call some other part of the city nearby Golconda, like that, what you called sample. There you got some information T4, and what you called, let us say some other what you call side of the Hyderabad city, you collected some information from few supermarkets, let us suppose that T3. So all this T1, T2, T3, T4, strictly speaking, statistic. Because this information representing this sample, T2 represents this sample information, T3 represents this sample, and T4 represents this sample. So in this entire Hyderabad city, now for our study purpose, how many samples we actually chosen? 4 samples. If you want, you can choose 5 samples, 10 samples, 100 samples also you can do. But it's all time waste. Understand? So that means here, the pattern of T1, T2, T3, T4 is known as the sampling distribution. So distribution of the sample statistics is known as the sampling distribution. That might be a sample mean, sample variance, sample standard deviation, sample correlation, regression, whatever may be. How actually, what is the pattern all these numerical informations are following is known as the sampling distribution. This is very, very important discussion, because entire next coming concepts like testing of hypothesis depends upon the sampling distribution only. What is a sampling distribution? A sampling distribution is the probability distribution of the statistic obtained from large number of samples drawn from a specific population. So here how many samples we collected actually? 4 samples. Need not be limit to only 4 samples. If you want, you can collect 10 samples, 15 samples, whatever. That's all depends upon the size of the population and as well as what you called the availability of the samples. Then what is a standard error? So for this sampling distribution, if you calculate the standard deviation, standard deviation means variation. That standard deviation is known as the standard error. Should not confuse. Actually, the standard deviation, standard error, both numerical figures explain same thing, but their purpose is different. Standard deviation of the sampling distribution is known as the standard error. So what do you mean by that here? The standard error of a statistic is the standard deviation of its sampling distribution. Both standard error, standard deviation explains variability of the data, but the standard error explains what kind of variability? Across the sample. So between all the samples, what kind of what you call variability is there? If more variability is there, that information is not at all suitable for statistical analysis. So always, as an analyst, what is your prime duty? You need to see that the variation should be less. The standard error explains the variability amongst the samples. But the standard deviation explains the variability within the sample. Only whatever variation is there, this T2 value is known as the standard deviation. Within this T4 value is known as the standard deviation. So these are all very, very important definitions. So till now what you came to know? The first one is what do you mean by estimation. Then estimator, estimate. Next, the parameter, statistic. Now what we came to know? The sampling distribution and as well as the standard error. So these things will be asked as what we call short answer questions. But moreover, without knowledge of this information, understanding the theory of estimation and as well as the testing of hypothesis is very, very difficult. Look at this slide. The standard error depends in most of the cases on two factors: the sample size and the standard deviation of the population. What is the actual purpose of the standard error? It measures the precision of the concerned statistics in estimating the parameter. The precision of what you call the statistic is good, then the area where actually you are using that statistical information is going to give error-free information. So if you observe, all these are all standard error formulas. So what is the sample mean standard error formula? Sigma by root n. So again standard deviation by root n. What is root n here? Small n means sample size. What is the standard error formula for sample median? Sigma by under root pi by 2n. What is the pi? The mathematical constant, 22 by 7. Now sample standard deviation, what is that? Sigma by under square root 2n. Sample regression coefficient, sigma x by sigma y into square root of 1 minus gamma square